The sun, our life-giving star, is not always a benevolent neighbor. It can unleash powerful bursts of energy known as solar storms. Imagine a cosmic volcano erupting, spewing out a torrent of charged particles and radiation. That's a solar storm in a nutshell. These storms originate from sunspots, cooler, darker regions on the sun's surface that are teeming with intense magnetic activity. Solar storms are a fascinating display of the sun's raw power. They remind us that even from 93 million miles away, the sun's activity can have a profound impact on our planet. Understanding these storms is crucial, as they can disrupt our technology and pose risks to our infrastructure. Astronomers have been closely monitoring a large sunspot group that has recently rotated into view on the sun's surface. These sunspots are regions of intense magnetic activity, appearing darker because they are cooler than the surrounding areas. This sunspot group has been crackling with activity, unleashing a number of solar flares and coronal mass ejections, or CMEs. Solar flares are sudden flashes of increased brightness, often followed by CMEs. A CME is a massive burst of solar wind, a stream of charged particles constantly flowing from the sun. These particles can travel millions of miles per hour. Think of it as a giant sneeze from the sun, hurtling billions of tons of plasma into space. This plasma cloud can carry with it a magnetic field that can interact with Earth's own magnetic field. This particular CME is directed towards Earth and is expected to arrive on April 17, 2025. Scientists use advanced models to predict the path and impact of these solar events. While not all CMEs hit Earth directly, this one is on a collision course with our planet. The potential impact of such an event can be significant. When it arrives, it will interact with Earth's magnetic field, potentially triggering a range of effects. These can include beautiful auroras, disruptions to satellite communications, and even power grid failures. The interaction between the solar particles and Earth's magnetic field can create stunning light displays in the polar regions, known as the northern and southern lights. As we prepare for this cosmic event, scientists around the world are keeping a close watch, ready to study and mitigate its effects. The dance between the sun and Earth is a reminder of the powerful forces at play in our solar system. Fortunately, Earth is protected by a magnetic field, a kind of invisible force field that surrounds our entire planet. This magnetic field acts as a shield, deflecting most of the sun's harmful radiation and charged particles. However, during a powerful solar storm, this shield can be overwhelmed. When a CME collides with Earth's magnetic field, it can cause it to compress and distort, triggering a geomagnetic storm. Think of it like pressing a magnet against another magnet. The fields interact and push against each other. This interaction can disrupt satellites, communication systems, and even power grids on the ground. Section 4. When the ground shakes, solar storms and earthquakes. In this section, we delve into the fascinating and somewhat mysterious relationship between solar storms and seismic activity on Earth. While it might seem surprising, there's growing evidence suggesting a possible link between solar storms and increased earthquake activity. These solar storms, which are massive bursts of solar wind and magnetic fields rising above the solar corona or being released into space, can have profound effects on our planet. The exact mechanism behind this connection is still being studied, but some scientists believe that the influx of electromagnetic energy from solar storms could trigger earthquakes in areas already under tectonic stress. This theory is based on the idea that the electromagnetic energy from solar storms can penetrate the Earth's atmosphere and interact with the planet's magnetic field. Imagine a fault line as a crack in a rock under immense pressure. These fault lines are essentially fractures in the Earth's crust where tectonic plates meet and interact. Over time, stress builds up along these fault lines due to the constant movement of the plates. Now, imagine introducing a sudden jolt of energy from a solar storm. This influx of energy could potentially act as a catalyst, disturbing the delicate balance of forces holding the fault together. This jolt could be enough to overcome the friction holding the fault together, triggering an earthquake. The energy from the solar storm might reduce the friction along the fault line, making it easier for the plates to slip and cause an earthquake. While more research is needed, this potential connection between solar storms and earthquakes highlights the far-reaching effects space weather can have on our planet. Understanding this relationship better could help in predicting and preparing for natural disasters, potentially saving lives and reducing damage. The study of space weather and its impact on Earth is a growing field, and as our technology and methods improve, we may uncover more about these intriguing interactions. Section 5. The ionosphere, our radio waves dance floor. High above Earth's surface, between 50 and 600 miles up, lies a fascinating and dynamic region of our atmosphere known as the ionosphere. This layer is not just a passive part of our planet's atmospheric structure. It plays an active role in our daily lives, especially in the realm of communication. The ionosphere is crucial for radio communication, as it reflects radio waves back to Earth, allowing for long-distance communication. Without this reflective property, many of the radio signals we rely on would simply drift off into space, lost forever. This natural mirror in the sky enables us to send messages across continents, bridging vast distances with invisible threads of radio waves. However, the ionosphere is also sensitive to solar storms. These storms, caused by eruptions on the sun's surface, send streams of charged particles hurtling towards Earth. When these solar particles collide with the ionosphere, they can cause significant disturbances. During a solar storm, the increased radiation and charged particles can ionize the atoms in the ionosphere, creating more charged particles and disrupting radio waves passing through it. This ionization process can lead to a dramatic increase in the density of charged particles, which in turn affects the way radio waves travel through this region. This can cause radio blackouts, making it difficult or impossible to communicate using radio waves. These blackouts can last from a few minutes to several hours, depending on the severity of the solar storm and the level of ionospheric disturbance. Think of it like trying to listen to a radio station with static interfering with the signal. The clearer the ionosphere, the clearer the signal. But when it's disturbed, the static takes over, making communication a challenging task. This dance between our radio waves and the ionosphere is a delicate balance, one that is constantly influenced by the activity of our sun. Section 6. Bracing for impact, preparing for the solar storm. While the upcoming solar storm is not expected to be catastrophic, it serves as a reminder of the importance of space weather awareness and preparedness. Governments and space agencies around the world are monitoring the situation closely and taking steps to mitigate potential risks. Satellites can be put into safe mode, power grids can be adjusted to handle fluctuations, and communication systems can be prepared for potential disruptions. Just as we have emergency plans in place for hurricanes or earthquakes, it's important to be aware of the potential impact of solar storms and to have plans in place to minimize disruptions. Section 7. Stay informed, stay safe. Resources for space weather awareness. Knowledge is power, especially when it comes to space weather. There are a number of resources available to the public to stay informed about solar activity and potential impacts. Space weather forecasting centers such as the Space Weather Prediction Center or SWPC in the United States and the European Space Agency's Space Weather Service Network provide up-to-date information on solar storms and their potential effects. By staying informed and being prepared, we can minimize the disruptions caused by these powerful events and continue to explore the wonders of the cosmos safely. Remember, the sun is a force to be respected, not feared.